Fine, let's start the session. We have done all these things. We have done these two. This one. Any doubts in the previous day session, or anyone missed the previous day session, or any troubles in the yesterday session?
No, sir.
Clear for everyone?
So can you please brief because I had not network. I did not have nice network, so I could not understand what you were saying.
Okay,
So just an overview would be fine.
fine. Someone also texted me regarding the same. Someone is also having some internet connection problem. So no worries. Again, we will be starting with this thing today. I will be giving you a glimpse. Can someone explain me what exactly is this? Those who have the good connection, those who have no doubts in this slide. Can you please give me on this brief on this one? Anyone? 65?
Yes, sir.
Can you give me a brief on this one?
Sir, basically describing a model is like a PLM. In this we try to explain the model how we manufacture. Then means completely like a PLM model. After this model we planning for executing the model. After that
Arvind,
we
just a second. Actually, what is the need of this procedure? I mean, if we not follow this type of procedure, are we able to do the simulation or it is not possible?
Sir, if we do not follow the procedure, then it will be difficult for us to create a plant.
Okay. Well, let us take an example. If at all directly I start this one, creating a simulation model, then what will be happen? Without collecting all this information, directly I jumped into this one, directly started a model. Now what will be happened?
सर सर यदि हम डायरेक्ट साइमुलेशन मॉडल क्रिएट करेंगे तो हो सकता है कि वो जो मॉडल है
Hmm.
मतलब वो जो पहले का जो डाटा वगैरह है वो हमने नहीं लिया है तो इस वजह से हमें एग्जैक्टली कोई इंफॉर्मेशन नहीं होगी कि हमें कितना टाइम लग सकता है, कितनी कॉस्ट वगैरह लग सकती है इस मॉडल में। तो
Okay.
मतलब मतलब आगे का प्रोसीजर भी फिर ना मतलब और भी अच्छा नहीं हो पाएगा फिर।
Okay, इसीलिए हमको ये प्रोसीजर फॉलो करना पड़ेगा देन ओके
जी,
कंटिन्यू विद द डाटा कलेक्शन कंटिन्यू आपने प्लानिंग तक बोला उसके बाद
उसके बाद सर डाटा कलेक्शन भी मैंने बता दिया ना कि कितना टाइम लगेगा, कितनी कॉस्ट वगैरह आएगी
हम्म
और कितने टाइप के पार्ट्स वगैरह हमें नीड होगी डाटा कलेक्शन में।
हम्म
आफ्टर दैट वैलिडेटिंग, आफ्टर दैट क्रिएटिंग ए सिमुलेशन मॉडल, आफ्टर दैट हम क्रिएट करते हैं सिमुलेशन मॉडल के बारे में कि अ, मतलब ये एक इनिशियल प्रोसेस होता है लाइक जैसे कि हम किसी पर्टिकुलर जैसे 10 मशीन्स 20 मशीन्स पर वर्क करते हैं
हम्म
इस मॉडल के रिगार्डिंग।
हम्म
और उसके बाद हम बेसिकली वेरीफाई करते हैं कि जो है मतलब चेक करते हैं मॉडल को कि वो इन मशीन्स वगैरह के लिए सही है या नहीं है। उसके बाद वेरीफाई करने के बाद वैलिडेटिंग में ये होता है कि अ, किस स्टेज पे वो जो मॉडल है वो फेल वगैरह हो जाएगा। उसके बाद उसके बाद ये सब करने के बाद हम अ, एग्जीक्यूट करते हैं इन सब चीज़ों को और फिर रिजल्ट कलेक्ट करते हैं कि ये कितना हमारा जो मॉडल है उसने वर्क किया। उसके बाद हम जो रिजल्ट वगैरह को एनालाइज़ करते हैं कि किस प्रकार हम इसको और भी अच्छे से कर सकते हैं। उसके बाद जो फाइनल रिजल्ट है वो हम मॉडल सिमुलेशन का जो चार्ट है वो तैयार कर देते हैं।
ओके फाइन थैंक यू मिस्टर अरविंद
थैंक यू।
ये साइमुलेशन नहीं है सिमुलेशन बोलते हैं ओके वो प्रोनाउंसिएशन है
ओ ओके
सिमुलेशन
सर।
ओके now I'll explain you this is the procedure for the simulating I mean for creating a simulation model So we have to follow this procedure. Why? Because if we directly jump into creating a model, then what will be happen? We will start creating the model. In the mean, maybe some mission is having something, some all the characteristics. We don't know what exactly all these characteristics. At the time, what will be happen? You need to pause the model and you need to start collecting the data at that time. At the same time, you don't know how to prepare a layout. You don't have the proper planning for this one. Then after a certain phase, what will be happen? Again, you need to pause the the model. You need to stop the model. Then again, you need to go for the layout. What are the different things that will be needed? Then at the time, what will be happen? Your model will also be paused. At the same time, your data collection will also be not up to that much extent. That is why you have to follow some certain set of certain procedures, step by step process for creating this simulation model. In this one, first one is describing model. Describing is model is nothing but what exactly you are going to prepare. So what are the type of machineries you need to have, so what type of output you are expecting, at what time you are expecting the output, all the planning model, all the model related things will be described here. So you should be having a clear idea on what exactly you are going to prepare. That should be in this describing a model. After that, it is a planning phase. Planning phase is nothing but you have a broad idea on your mind, so that I am going to start a manufacturing plant for some X product. So for that X product, what are the different things I will be needed? Like you have a some model description. Then for that model, what are the type of planning you have to produce? So do I need to start like this, or do I need to start like this? Like different planning purposes. So what will be happen if there is no any planning phase? Like in the day before yesterday session, we have discussed in the planning phase there will be lot of things like manufacturer planning, production planning, actual planning, like different plannings. So for starting a thing, so you need to consider all those things. You have to collect all these data regarding to this planning phase. Once you will be having complete idea on the model, at the same time you will be having a planning phase, then you need to start working on the data collection, which means if our plant is having 200 number of missions, for all the 200 number of missions, what are the different type of inputs that will be needed, what are the type of resources that will be needed for running these 200 missions. So apart from this, what are the different things that will be needed to run these 200 missions in a continuous way. So if at all you want to run this model for 365 days, then what are the things you need to consider before starting a model, and what are its failures? So what are its resource cost, where exactly you are going to purchase the raw material? If at all you want to purchase a tool, what is the tool cost, how much tool length it needed, what are the various tools that will be needed for this process? Like all the data that will be needed for this model, you have to collect. Now once you will be having this vast data, then you need to start the model. Why? Because so whenever you will be having any doubt in the model, then automatically you have the complete data here, data plan and the model description is here, so that you can refer this one, and again you will be continuing this model. So that is why you have to, first of all, you need to collect all these results before starting into one. Once you will be having these things, now you need to work with the model, which means if your plant is having 10 missions, you need to start with creating a simple model like one to second mission, third mission, fourth mission, fifth mission, like 10 missions. After the 10 missions were done, if they are running perfectly, then you need to go for the second process. This is process A, let us assume. Once your process A is running perfectly, then you need to go for process B. Then you need to go for process C. Like you need to, if your plant is having 9 different processes, then you need to create a model like this. That is called as a creating a simulation model. Once your model is finalized, which means you have prepared the model, then you need to add some. Once your model is finalized, then you need to add some failures in the next phase, so that you will be getting exact results. That is called as a verifying the model. So you need to give all the actual result, actual scenarios to the plant. Once your plant is having all the actual scenarios, actual characteristics, then you need to verify the model. Verifying the model is nothing but testing the model. So if you want to run this model for 30 days, so now you have to check in the verifying model. So what its behavior on the first day, what is behavior on 2 days, what its behavior on seventh day, what is its behavior on 10 days, what is behavior on 15 days. Like you need to run the simulation up to 30 days. So you need to run the simulation for 30 days and you need to collect the results. So on 30 days there will be having some errors, then you need to monitor, you need to modify the plant according for that one. So you want to run this plant for 30 days. For 30 days you have to modify the complete plant with existing all these things and collect the results. That is called as a verifying the model. Once your model is verified with the actual time you want, then you need to go for the validation. Validation is nothing but maximum extent at what point of time your model is going to fail, that you need to calculate. Why? Because in running industries, what will be happen if there is a demand? So because of the demand, you have to run the model completely for 30 days, so that you will be getting some 10,000 parts. If because of sudden increase in market, your demand will be increased from 10,000 to some 30,000. At the time, what will be happened? Instead of 30, you have to run for 90 days. Now this model is verified for 30 days only. You don't know what will be happen if this model is run for 90 days continuously. At that point of time, so we can't go directly blindly. what will be happen, maybe after 45 days this model is going to fail. At that time what will be happen, you are in the middle of a process, you are in the middle of a production, there will be a huge impact on the productive final production and as well as the demand ratio also. That is why you have to check the model at the to the maximum extent. So at what extent this model is going to fail, that you need to check in this validating model. Validating model is nothing but, so you have created the 9 different process here, so you have the results of 30 days, now you need to work for 45 days, now you have to work for 60 days, similarly 90 days, 80 days, like 120 days, like you need to work for model. Maybe after 150th day, out of these 9 processes this process is going to fail. After the 150th day or 152nd day this process is also going to fail. Now you will be having an idea, so this is the maximum extent. At 150 days this model is going to fail. Now at this condition you will be creating a report and you will be sharing it like the maximum is 120. So that what will be happening, even though they will extend it for 10 days or 15 days, it is not exceeding the standard benchmark. That is what exactly validating is. Once you will be having the verifying model, that is nothing but your actual characteristics as well as the maximum characteristics, then you need to collect the results. Collect the result is executing, so you have to run this model for 30 days and you need to collect each and every data involved in this one. At the same time you need to collect the maximum record of this one also. At 90 days what will be behavior, at 150 days what is the behavior, after 150 days this machine is going to fail at mission 2 as well as mission 9, like different process you have to conclude all the things and you need to collect the results. That is called as executing, collecting the results. After that analyzing the results. Analyzing the result is nothing but, so if it is an existing model, then you need to compare this result. If you are getting some 50 percentage of efficiency in virtual, whereas actually you are getting 40%, then you need to map, so why exactly there is a difference in 10%. Or else vice versa, in your virtual model you will be getting 40%, whereas in actual production you will be getting 50%. Why there is a delay in this 10%? So what have you given, what are the inputs you have given to the virtual world? So you have to check that also. That is called as analyzing the results, if it is existing one. If it is a newer one, then you need to calculate the results, you need to analyze the results with respect to theoretical. Theoretical is nothing but, for every mission there will be having some 3 minutes of time, and you will be having 10 missions. So for a part it is entering into the plant, so what is the maximum time it will be coming out? Hardly 30 minutes. But in actual there will be having some delays also, like the material handling between stations, you need to consider all those things. In theoretical it is 40, let us assume it is 40 for a part entering into plant and it will be exiting after 40 minutes. But in actual, or but in simulation model, so you will be getting part after 35 minutes itself. Now what exactly happened, why there is a this 5 minutes of delay? This you need to analyze, that is called as analyzing the results. Finally after analyzing all these things you need to create some data sheets, so comparison all the things you will be collecting here, and you will be creating a bundle of records or a bunch of records stating this complete model. This is called as a procedure of simulation. Clear?
Yes, sir.
Yes, sir.
These things we already discussed. If at all we are starting a new facility, then these are the advantages with respect to the by using the plant simulation. Like we can increase the throughput, we can increase the dimensioning, we can increase the performance, determine the limits of performances, influence of failures, power requirements, behavior of facility, strategies, and different alternatives. Like these are the different by using different tools, we can calculate these type of features by using this. Plant simulation software. If it is a new facility, like what is the maximum number of parts that will be entering into your plant, so how can I supposed to increase that? That can also be determined. We can determine the dimensioning. If a plant is designed for 1 kilometer length, but now actually it was reduced to 500 meters only, 500 meters. Now how can I supposed to scale it down? So if at all I scale it manually, what will be happen, there will be having dimension errors. If I supposed to scale it some other by using some other components in plant simulation, then it will be easy. That is called as the determining of dimensioning. Maybe the plant is prepared for 500 meters, now I want to extend it to 800 meters. That can also be possible with this uh, some tools in the plant simulation. And limits of performances, like validating what is the limit of a process, what is the limit of the cycle which you have prepared, that can also be determined. Influence of failures. Influence of failures is nothing but, if a process is having some 10 missions, so if a suddenly seventh mission is failed, so what will be happen, what is its impact on the production? Simultaneously mission 4 is also failed, now what is its impact? There will be two missions that are failed in the process. Because of this, what will be happen to my production? I'm having only one alternative mission for this process, now suddenly there is one more mission that was failed. Because of which, what will be happen, like I need to have a complete idea on failures also. So what will be happen if sudden mission one mission was failed? What will be happen if there is a complete process is failed? Like I can investigate, I can check the influence of the failures in the complete model. Determine the manpower also. If there are 10 missions, is there a need of 10 manpower, or do I need to use only 5 human over there? Like I can simulate and I can check whether five humans can do the operation on 10 missions, or definitely 10% is needed for operating 10 missions. Like different manpower requirements can also be checked while creating a new facility. At the same time, behavior of facility is nothing but this validating. So we can predict what exactly happen if the plant is run for 50 days. If I can calculate the behavior of the facility after 500 days, that is what exactly behavior of the facility. Control strategies as well as alternatives is like, if there is having connecting missions, like one, two, three, four different missions are there, all the parts will be distributed to a single mission, like this, two missions. Now how I need to distribute parts from this mission? There are 100 parts here coming here, and there are 10 parts here. At the same time there are 50 parts here. At the same time there are 30 parts here. Now this mission is going to take one mission, one input from this mission, one input from this mission. At the same time, one input from this mission, one input from this mission. This is a default basis. If at all I follow the default basis, what will be happen? This mission will be I mean this conveyor is having lot of bottleneck. Why? Because there will be having 100 missions continuously produce 100 parts, whereas this from this conveyor there are only 10 parts that will be coming. So what will be happen? One from this, one from this, then automatically these will be having lot of waiting phase will be there simultaneously. So I need to work on this one. So I am getting 100 parts from this conveyor. So from this conveyor I need to add more materials, which means for every cycle 5 parts from this one as well as 1 part from this one. Similarly this one, 2 parts from this one and 1 part from this one. Like I need to add some strategies so that I can control the production at every point of time. That can also be possible with this software for creating a new facility. Different alternatives, like if at all there is a processor, so what will be the alternative? If at all I am not going to use any control strategy, still I want to run the plant simulation, I mean run the model without having any bottleneck, then what is the alternative? Do I need to add a mission over there to run the simulation continuously, to run the model continuously? Like different alternatives we can create for a, if it is a new facility. If it is an existing facility, we can control strategies, sequence of order, daily proceeding. These are the different things we can use for a control strategies. Okay. Uses of simulation: by using simulation we can increase many number of things: throughput, resource utilization, utilization of facility. By using the simulation we can determine the buffer sizes, transporters, AGV, workpiece carriers, schedules. All those things we can calculate by using the simulation. These are the uses of simulation. We have discussed this also. This is called as a pillars of industry. Together we are creating this complete model in the plant simulation. That is what exactly plant simulation is. We are creating each and every component of this industry, factors of industry or aspects of industry in a virtual world. That is simply called as a plant simulation to increase the efficiency of the industry finally. Okay. If at all we are talking about industry chains are currently having lot of factors, out of which these are the some of the specific factors which will change the industry. Like speed of market, which is nothing but varying product. So if there is a one product is there, this product is launched in the market, so and after 1 year what will be happen? This demand will be reduced. If the demand is reduced, what will be happen? It is difficult to sustain in the market. So what will be happen? So we have to create a number of variants, so that what will be happen, we can sustain in the market. So if at all you want to sustain in the market, if at all you want to maintain the speed of the market, then you have to create n number of products on the same thing. That is what exactly speed of market. We have to maintain the speed, we have to maintain the demand in the market. Multi product lines is nothing but same thing. So if at all we are producing single product for the complete process, then it is impossible. So simultaneously you have to create n number of products, so that what will be happen, even the one product is failed, the alternative will be clicked, and because of which your demand will be maintained in the market. At the same time your brand value will be maintained in the market. That is called as a multi product lines. Growing demand and increased variance, these are all almost similar. See, because of increase in demand, what will be happen if this product is having more demand? So if at all I'm going to produce continuously, what will be happen? At some point of time the demand will be reduced. So to maintain the demand, at the same time if at all I am maintaining the n number of products, what will be happen? The brand value will be maintained. At the same time the industry will also be changed because of these things. Unpredictability and varying demand, same application. So if at all I'm producing this X component continuously for a year, what will be happen? After 1 year, the demand will be, maybe it was starting reducing, like this. So because of what will be happen, my brand value will be decreased, or some customer is not going to purchase this product anymore after 2 years or 3 years. So to sustain in the market, you have to go for the, you have to work with the demand. So if at all the company is having some other demand, if at all the customers are wanting some other thing from your product, then you have to work on that one. That is called as unpredictability and varying demand. Increase in cost, sometimes what will be happen, it continuously increase in cost, where also rise in the demand or decrease in the demand. That is going to happen. So you have to monitor that. If at all you are increasing the product, simultaneously you have alternative ideas for to maintain the market. So if you are producing some 1 lakh component, so it is difficult for everyone to purchase this 1 lakh component, so that you will be having some other thing also, so that it will be some middle level also, some 50k, some 25k person can also estimate 2000 or something, so that the person can invest this thing also, so that what will be happen, you will sustain in the market. That is what exactly increase in cost is. Automation and robotization, if there is a lot of demand in the market, if there is a lot of demand for your product in the market, then automatically what will be happen, you need to produce more number of components in this small limited time. So if there is a limited time and you have to produce more number of components, then your plant must have some automation as well as robotization involved in it, so that what will be happen, your rate of production will be increased by the end of the day. So these are the things that will change the industry. These are the things that will impact the industry. If your industry is a small scale industry, you have started an industry, after a year what will be happen, the part which you have produced having a huge impact in the market. So because of which what will be happen, the customers are having a, there will be having huge demand in the market. So that what will be happen, you are going to produce more number of components. Initially you have produced 1000 number of components, let us take an example. Now because of the increase in demand, you have to produce 10,000 components to meet the customer demand, to maintain the demand in the market. So if at all you are using the same small setup, small scale industry for for producing this 10,000 components, what will be happen? So it will be taking too much of time, maybe 3 months, maybe 5 months, maybe 6 months. So because of this longer tenure, what will be happen? The demand will fluctuate. So to maintain that one, so what will be happen? So definitely you need to increase the plant from a small scale to medium scale. So if your plant is having a medium scale, then what will be happen? You can produce this 10,000 components in the 3 months itself. So 3 months is a not a greater time. So you can sustain in the market. That is what exactly these things can change the scale of the industry. These things can change the industry from one perspective to another perspective, from one level to another level. You can change. Maybe this demand can decrease the plant also. If a plant is having higher large scale manufacturing, it is having all the automation involved in it. But because of increase in cost, what will be happen? The demand is continuously reduced. Maybe it is continuously for 2 years or 3 years. Then what will be happen? The company need to shut down its some of the units, so that what will be happen, to sustain in the market or to maintain or to run the industry, remaining industry. So these things can change the industry from a small to medium, medium to large, at the same time large to medium also. Okay, these are the some of the things for which industry change it depends upon, like time delivery, more efficient, improvements, increase in profitability, throughput. These are the different things that you need to maintain. Company need to maintain to increase or to change their industry. This we have discussed plant simulation, and one more thing. So we are using this, till now I have explained you different forms of software, I mean capabilities of software. But what exactly the main purpose of software is, this simulation can be used for two different areas. One is for the production and second one is the logistics. Production is nothing but the missions involved in it, the material movement involved in it between stations, that can be operated, that can be simulated in this production phase. Whereas the material movement between lines, material movement between among the plant, that is called as the logistics. These two things we are going to perform, these two simulations we are going to perform in this plant simulation. Which means if at all there is an industry is there, mission, there is a mission, these are the missions. So these mission characteristics can also be simulated, that is called as a production simulation. At the same time, the mission movement, the material movement from this station to this station, how the input is coming to this station, after that how the from this station the material need to transfer to this station, how the material movement is happening, what are the different ways for a material handling will be happen, logistics will be happen, all the material movement from stations, between stations as well as between lines. So this is one process line, this is one process line. From this process line to second process line, how the material movement is happening, that is called as a logistics simulation. These two are the important factors for an industry. Okay, not only production but also material movement will also plays a key role in the plant. So that is why we are doing these two simulations in the plant simulation software. Okay, these are the some of the things. Validating plans, which means if we are creating a plan, we have to check what extent it will run, at what extent this will going to fail, that we have to check. That is the first part. Second part is like optimizing manufacture cost. Same thing, if you are modifying our plant, if you at all you are modifying the plant which you have created, if at all you have modified the thing, created a layout and you are modifying this layout or optimizing this layout, automatically what will be happen, the cost involved in it, the manufacturing cost, the capital cost, that can also be reduced because of modifying this one. That is called as the optimizing manufacturing cost. If at all some unnecessary process will be happening in this, unnecessary process are there in this one, there are missions that are not utilized up to its mark. So I want to remove that mission, so I want to remove that missions from the process, so that what will be happen, the resources involved in it, the cost involved for the resources to operate that mission can be reduced, because of which what will be happen, my manufacturing cost can be optimized. Next is perform what if scenarios. This is one of the key factor for the plant simulation. If at all anyone asks what is a plant simulation is a thing where we can perform what if scenarios. This is one of the answer. What if scenarios means conditions. We are going to check each and every condition. So if this is a layout, what will be happen if I remove this mission and I place this one? What if? So if at all I place completely remove this process A, now what will be happen? That is called as a what if scenarios. What will be happen if I remove this one? What will be happen if I modify this one? That is called as a what if scenarios. We are going to work with what if scenarios in the plant simulation once creating the layout. So this is the plant simulation in which you are created a layout. So once you will be having actual layout, then you need to start working on the what if scenarios. What if this machine is not having any failure? What if this machine was failed continuously for one day? What if this conveyor was jammed? What if humans are not entering into the plant? These are the different things we can work with. These are the different things we can perform here in the what if scenarios. After that, energy requirements also. Plant simulation is having these important things involved in it. So if there is a plant involved with some 200 missions involved in it, so to for running 200 missions, how much power is required? What is the type of power that is needed for every hour? How much alternative I need to have? How much backup I need to have? That also we can be identified with this. So these are the some of the aspects where we are using the plant simulation. These are the things we are performing in the plant simulation software, that is called the Y simulation. Okay. Next, this we have discussed. And features, like I have explained you, plant simulation is having these number of features, like we can work with a process plant, we can work with automation, we can work with robotics, we can work with the human operations, we can collect the data sheets of human, we can work with automated things like agvs, forklift, cranes, lifts, all those things. We can work with fluids, different form of fluids. If there is an industry that is called a chocolate industry or a petroleum industry or a liquid based industry, then how we are going to form that, that also we can be performed. We can work on the advanced applications, like if the building is having multi-story building, or if a human need to pick a part and he need to go to the fourth floor, how it will be happened. If a material transfer have need to, material handling is going to happen from ground floor to fourth floor, how it will be happened. All those advanced application can also be performed in this one. At the same time, we can collect multiple data sheets for the number of components involved in it. And data sheet is nothing but charts, which means if at all I want to monitor two missions, I want to compare two missions, by what aspect we can compare? By using a chart. There are two missions here, I'm comparing it. Here there will be having 50% usage, here there is having 75% of usage, so that I can directly compare by using the graph charts. This mission is having a limited working condition, this mission is having a huge working condition. When compared to this one, this mission is having a huge failure rate, that is 30%, whereas this mission is having some 5% of failure rate. I can compare why exactly this was happened, what is the things that will be involved in this one. I can directly analyze that by using these data sheets. Data sheets are nothing but charts. Okay. In that, there are different charts that can perform with. For every component involved in a plant simulation, we can we can create a chart. See, for workers, we can perform a chart. Worker, how much worker is working, how much he is not working, how much time he is sitting idly. That can also be we can work with. So if the machine is involved in it, how much time is the machine is working, how much time it is waiting, how much time it is in failed condition. That can also be calculated, performance calculated by the charts. Conveyors also, robot and its applications. If there is involvement of robot in there, how much time the robot is actually doing its work, how much time it is not doing its work. All those things can also be checked by these charts. Process, if there is a process like this process continuously, so I can operate, I can monitor this complete process by using charts. Sankey diagram can also be possible. Sankey diagram is nothing but material flow. If the material is flowing like this, I mean, there are missions here. There are missions here, and by respect to mission, how the material is traveling, how the material is moving between stations from starting to ending, that can also be monitored. That is called a Sankey diagram. If there is a dilute here, if there is some other process involved in it, now the Sankey diagram will be like this. If a majority of the components are moving through this line and a limited number of components are moving through this line, then it will be represented by the form of a line thickness. Here there will be having thicker line. Why? Because there is a large number of metal movement. Here there will be having a limited line. I mean, limited number of parts that will be traveling through this line. So there will be having a thin line here, so with which we can monitor, so how exactly the material movement is happening, how exactly the material is traveling from one station to another station, I can directly monitor. So this is the first point, and where is the last point, I can directly check by using this Sankey diagram. That is called a Sankey diagram. We can prepare statistical reports, data attribute. These are the advanced applications which we will be discussing in the software. And one more thing, bottleneck analyzer, energy analyzer. These are the some of the advanced tools in the plant simulation where we can directly work with the bottleneck. If there is a process is there, in this process, I don't know where exactly the blocking phase is, there exactly the waiting phase will be, where exactly the machine is failed. Because of the failed state, what will be happen to my product? What is its impact on the previous mission? What is its impact on the previous mission? What is the complete impact on the next cycle? That I can calculate by using this bottleneck analyzer. Same with energy analyzer. By using energy analyzer, I can predict this process A energy consumption, how much energy it is consumed. So for every hour, what will be energy consumption? If it is running, if the plant is going to run for 30 days, what is the power that I need to have? That I can check. These are the different features for the plants on the plant simulation. Okay, clear so far?
Yes, sir.
Yes, sir.
Okay. Now I will be showing you software. Okay, fine. I will show you software. Just give me a second. Or else anyhow we are practicing the software, I mean after a week or after 2 weeks, so there is, I hope there is no need of showing you software right now. Okay, I will explain you the things, this part. When the time comes, I will explain you the software in detail. Okay, starting from everything, how we need to start the simulation, how, what are the different tools, so how to start a plant simulation, all the things I will explain you once the software session is started. Okay, now have we completed these things? Objectives, changes in industry, have we done this one?
Yes, sir.
Yes,
Basics
sir.
of plant simulation we are done. Where and why we
Yes.
are using plant simulation is also done. Features of plant
Yes.
simulation. Okay, now we'll be entering into next day's session. Implementation of simulation. What is this name? Describes. Now you tell me.
Means,
Implementation means what
means
exactly?
to apply the simulation.
Okay, so we haven't discussed that till now. It's a question. Have we discussed or have we haven't discussed that part?
We have discussed it on the virtual device. So now implementation of simulation would be how this virtual simulation is going to work in reality.
Hmm. Okay, now I will be explaining the software so that you will be getting clear idea on what exactly this implementation of software simulation is. Okay, in this software we are going to, I mean in this slide we are going, in this presentation we are going to learn the implementation of simulation process. In this we are going to learn steps of implementing a process, procedure for simulation, knows the usage of simulation. Okay, these are the important things. Implementing a simulation project is like, these are the PC. These many number of things you are going to consider for this implementing a plant simulation. First one is implementing a simulation project. Have a look on this one. Develop your simulation model in a cyclic or evolution process. You will start out the first draft of your model and refine, modify it, make use of intermediate results for the simulation run provide. Eventually, after several cycles, you will be arrived at the final model. Before you start implementing your simulation project, you will more or less proceed like this. So, which means, so till now we have discussed about what is a simulation, where exactly we are going to use simulation, what are the features of simulation, what are the capabilities of simulation, and for starting a simulation, what is the procedure I need to follow. That we have learned. But here, so to get this one, implement, I mean, if at all I am going to start a simulation model, like following the simulation model, then what is the things I need to consider for starting this one? So how exactly I am going to implement actual simulation model? So these are the things. First one is developing your simulation model in a cyclic or evolutionary process, which is nothing but if it is a like I will explain you like this. So if it is a new process, then there will be no boundaries. Why? Because you can create a layout like this, 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 different aspects you can create. Why? Because based upon the plan which will be having, play based upon the model you will be having. But Cyclic is always preferable. Why? Now these many layouts are there. Okay. Out of these, I am picking this one only. Why it is more efficient when compared to these things? Before starting this, let me
Area efficient.
just a second. Before starting this, I want to ask a simple question. I hope you know the layouts, right? Production layout, process layout. Have you covered this production
So
layout this
layout,
subject?
the layout
Yes, sir.
basically means design, a type of design.
Type of design. Design for what? Okay, design for
So
machines are okay.
basically, production layout are those which are designed according to the production, and process layout are those which are designed according to processes kept in mind.
Okay. Sorry for interrupting. There are no any production layouts. There are layouts, product layout.
Product or line
product
layout.
layouts.
Yes, there is a product
Product.
layout, and there is a process layout, and there is a fixed layout. Now, can someone describe me these things? Why? Because now these things plays a key role here. Product.
Product layout is product or line layout where the product is moved in a line,
Okay.
continuous line.
Okay.
In process layout, the machines are placed according to the process. All machines uh, uh, doing a similar kind of work are placed at one place. In fixed layout, the all the processes are done at one place. Like example in shipbuilding,
Hmm.
like that. It is fixed layout.
Okay, I will explain you in simple. In some conditions, what will be happened? Product as well as process are similar. But if at all I want to differ, then product layout is nothing but it will follow the product life cycle. If a product is coming like this, so product movement based upon the product movement, the line will be decided. See here. So this is the product. So if at all I want to move this product, then I will manage the missions here. This is called as a product layout. Based upon the product movement, the process will be the complete line will be defined. This is called as a product layout, as you said, or line layout. Then the second one is process layout. Process layout is nothing but what is a process layout now? You explain something. Hmm? You have given some input. What is a process layout according to you?
The design made in my means process are kept in mind when make while making designs. Means
Uh,
the same similar process are to performed together.
can these two are differ or they will be same?
So, for example, if
Means
two is required even after, suppose machine 2 is required even after machine 3. So, in product layout, we will have a straight line, but for process layout, we will have to go back to machine 2 and then again continue with the process.
So is a process layout is a efficient one or it's a failure one?
It's an efficient
depends
one.
on the depends on the situation.
Okay, fine. I will agree with your answer. I will explain you simply. There are one, 2, 3, 4, 5, 6, 7, 8. This is a process we have to follow. In this process, after 1, 2, 3, again it will be coming to this one. So this is the process. Now what is happening in line layout based upon the product it will be moving. But here what will be happening based upon the process. If there is an oven involved in it, if there is a heating process involved in it, so the product need to go back to the some other machine, and again it will be coming back to its position. So based upon the process it will work. So if it is like this, 1, 2, 3, 4, 5, 6, 7, 8. Now what will be happen? The product movement will be like this. So based upon the process only it will work. So we can't change the movement of this one. That is why I said sometimes what will be happen, product as well as process will be similar, but in actual they will be different. The product will always be in a line shape. The product layout will be in line shape, whereas the process layout will won't have any particular shape or a particular procedure we need to follow, particular line we need to set up. So based upon the process, if after three missions, then this part need to go for annealing purpose or a heating purpose or for some quenching purpose. then we can't place an oven in the middle of the plant. So that what will be happen, the part need to go to the station where it was required, where it is there. Once it was done, then again it will be coming back to its position and it need to follow this one. So this is called as a process layout. Based upon the process defined, the product need to move to that mission. That is called as a process layout. Now what is the fixed layout? Someone has given the example, correct, that is a shipbuilding. What will be happen here? The product is stationary, the workpiece is stationary. What is different here? The machines will be moving, or machines will come to its position and the operation will going to perform. Like an example, shipbuilding company or an airplane manufacturing, what will be happen here? The parts are not going into the mission. Why? Because it is not following any product or process layout. Here the part is a vast area, it is having a larger in shape, so the product will be in this location like this. Now simultaneously the missions need to be placed here, the mission need to be installed here, so that the part is won't be stopped. At the same time the work need to be performed. That is called as a fixed layout. These are the three layouts that will be used in the industry. Clear? Now, in this cyclical as well as evolutionary process, nothing but if at all I'm going to prepare a model, then it should be like material movement should be less. Okay, material handling should be less. That is the first thing we need to consider while creating a layout or while creating a plant. What will be happen if my first mission is there, second mission is there, and third mission is there? Again, there is a fourth mission is there. Now I want to run this model. Now, what will happen if I run this one? I want to continuously run it for 1000 number of pieces or 10,000 number of pieces. Now what will be happened here? For every mission there will be having 5 minutes of processing time. 5 minutes, 5 minutes, 5 minutes, 5 minutes, 5 minutes. So together, so at the end of 20 minutes I need to produce a part. But in actual I am getting 120 minutes for completing a part. Why there is a difference here?
Movement of the product from one mission to another mission.
Yes, material handling between stations will be long here. So that this model will always be a failure model, or we can give improvements for this model, so that what will be happen? I can try to place the four missions like this, or I can try to remove these two missions. I can try to place here, or I can at least try for a limited. I mean, if it is not possible, then I try to reduce at least somewhat distance, so that what will be happen? From 120, I try to get it from 40 or 50, so that what will be happen? Anyhow, it will be a increase in the efficiency if it is not movable one. That is why. So I need to create a model where the material handling between stations should be limited or should be less. That is why cyclical will always be a preferable one. So if the plant is like this, what will be happen? So each and every process is in a line, so that there will be having empty space, so there will be having any, we can do any type of operation here, we can control the operation here, there will be having a free path for the human usage also. This is the layout we need to find. I mean, mostly it was acceptable like this. If it is a, if there is an industry, in industry having 200 missions involved in, or 300 missions involved in, or it is a continuous manufacturing firm, automotive manufacturing firm, there what will be happened? I will explain you here. The plant will be like this, and here there will be having different processes and number of processes, out of which there will be one section called as a CNC section. In that CNC section there will be having 20 missions involved in it. This is called as a CNC area, where all the missions were placed in a similar way. All the CNCs will be at this direction only, like this, or they will follow some set of lines, zigzag like this. So based upon the process they will follow. Again the part is entering here, so they will start the process from this direction, so it will be moving like this. So that what will be happen, the material movement will be between the stations will be reduced. That is what exactly cyclical or evolutionary process. So this is one of the key thing. So once you have defined this one, this is the acceptable one. Now what will be happen, if at all in the future you want to modify it, you can modify it by using some other accepts. So whereas in a if your previous model is like this, different models like this. Now what will be happen, if at all you want to modify this one, you have to modify the complete plant. This will be a difficult for the industry. If it is having a cyclical process like this, or if it like this, then what will be happening, if at all you want to remove these thing, or if at all you want to add like this, maybe there will be having limited number of missions that will be changed. This is acceptable. This is one of the key aspect for the plant simulation. If at all you are modifying, or if at all you are creating a newer one, this is called as a developing your simulation model. Just a second. simulation model and cyclical evolution, because this is one of the impact implementation before starting that or before creating that one. So you need to consider this one. After that, you will start out the first draft of the model. By refining the model, it makes the intermediate results as well as simulation run provide. Like I explained you, every process, if your plant is having 9 different processes, you can't start with the 9 processes simultaneously. You need to start with a single process. In that single process, first mission to second mission, and you have to give the condition and you have to work it. Like you need to add some, if the plant is having 10 number of missions, you need to create this one, you need to run the model, you need to check everything, you need to modify all the details based upon the layout. See, like you have created 10 number, n number of process like this, but finally what will be happen after this, the part need to be enter into this location. Again what happened, there is a lot of material wastage will be there. That is why, so by considering this, once you have prepared this model, second you have to prepare a model like this, then what will be happen, the material I mean the material movement was reduced here, material handling between stations will be reduced. Now you have created a model like this. After that, second, first model and second model both are working perfectly, then you need to start for the third model. Maybe the third model starts at this position, so the third will be like this, fourth will be like this. So this is the easier one. Whereas once you have created the 10 number of processes, then you need to start working on it, start evaluating, start validating, then it will be a tougher task. Why? Because if at all you want to modify it, you have to modify the complete cycle involved in that one, the complete process involved in that one. That will be a difficult task for you once the model is created. Okay, that is this one. First, you have to create a draft model, then you need to refine, modify it, make users intermediate results, and simulation run provides. Third one is eventually, after several cycles, you arrive at your final model. As explained, see, you have created first 10 models in a line like this, so which is not efficient one. Now you need to define like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if you think this is a better one, then this is a complete one. You have to check all the simulations, you have to check n number of permutations and everything. Then after number of cycles, this I will come to a model that this is my final model. This is the model which I am going to produce based upon the layout, based upon everything I need to consider, and I have to create. This is my final model. So I will be creating like this. After that, before you start implementing your simulation project, you will more or less proceed like this. It means you have created like this. So now you will be having a virtual file with you. So if you are having a virtual file, then you need to implement this on the actual plant. For implementing it on the actual plant, definitely you need to check. So why? Because you have created this type of layout, but in actual you don't have this much of I mean a land or this much of space, then what will be happen, your model is going to fail. So then at the time, based upon that one, you have to check, so which model will be feasible for my plant, that you have to check. Till that, so you need to work on the modifications. Once your modification will be matching your exact layout and everything, this is what is the first step for implementing a plant project. Second one is we need to describe the project, determining the goal so that the purpose of the simulation project become clear. Why are you examining problem? What are the questions you want to answer? For put up the definition of the project and rating the consult rapidly during the course of project. See, here we have defined the virtual model. Once we will be having a virtual model, then if it is actual model, so once we have created the actual model which is in the plant, so we have created this type of actual model. Now we have to work on, so what exactly the company wants to do, so what are the things they want to do, what are the things they want to modify, that we need to make sure clear on all these things. Like examining a problem, if there is a problem in the material handling, or if there is a problem in the logistics, or the plant itself is having a problem in the process, then how to adapt it, where exactly the process will be. Like we need to create a brief data on this one, or we need to collect the data, that is called as describing the project is nothing but.
Excuse
So
me, sir.
yes.
Excuse me, sir. Sir, first we have to describe the project, or first we have to implement a simulation project.
First we have to create a replica. Okay, so if it is existing model, we have to start working on a replica. So once we have created the model in the software, then we are going to ask the customers directly. We are going to directly, it is not possible to ask the customer, so what is the modifications you want. With the based upon the modifications, we can't prepare the layout like this. Why? Because we don't know where exactly the process will be, or how exactly the process is running. So while running the actual process, what are the difficulties they are getting, that we can be getting only with the actual model only. So this is the model we have created, actual model we have created here. So once creating the actual model, so we can calculate all the things. Now we need to ask them, so what are the things that will be needed, what are the modifications you want, where exactly you want to modify, or you want to modify the complete plant. While creating this model itself, we will be getting complete idea on where are the modifications will be. So what are the different steps we will be taking? That will be comes in our mind. Why? Because the simulation itself runs like this. So second phase will be describing the model. Now we need to plan the project. Planning the project is like creating the concept of a model, initiate values, model logistics, proceedings with the parameters you know have to change. Which parameters do you have to change? What is the things you have to collect for implementing the model? Make a list of functional units that install in the modeling contain. Think about the functional units, identify similar functions, combine them while deriving the applications, create, reconsider the existing objects, self-planning on purpose, defining, describing the interface of the material information. So now we have this actual model with us. Now we have the things which are which need to modify for an existing plant. Okay, if it is a not existing plant, then there is a no need of describing this model. This comes in the first place. So first we have to consider the describing phase. Now what are the things we need to, like we discussed in this procedure of simulation, we have to collect the data, we have to collect the plan, everything we have collect in the starting phase. But if it's an existing one, then it comes in first place. Then we need to collect the data from this one. Once we will be having those two, then we need to plan for the project, which means we will be having an actual plant, and we'll be having a virtual file with us. Now what are the modifications we want to do? So how exactly we are going to modify? If there is a CNC machine is there, in actual what happened, I have removed the CNC machine, I have kept here, but in actual this machine should be here. The company said this one. Now what I need to do? The company has not given any permission for shifting this mission from this location to this location. The mission need to be here. If at all something need to happen, it should be like a process layout. But the mission need not replace from this location. Like I need to collect the inputs. So what are the different things that are fixed? What are the different things that I need to consider? What are the different functionalities that I need to integrate? So instead I have given conveyors between every station, but in actual the company is not having that much of fund to add all the conveyors. Now again there is a loss of this one, there is a no need of conveyors. Now I need to consider all those things and I need to create a model. So the model should be, of course, I mean, which should be acceptable based upon the customers, combine them, derive applications, describe and define the interface. This is called as a plan per project, which means, so we have created a modified plant. So that plant should supposed to be in the plan, I mean the actual location. Find out the data you need to acquire it, ensure early data. Frequently lot of time and efforts involved in acquiring the data, make sure you have the data. See, like I already told you, if it is a newer one, then we'll be having a lot of things. If it is an existing one, then what will be happen? Sometimes what will be happen after creating the model itself, we are going to collect the data. In this modification phase, some machines need to be replaced, something need to be replaced. At the time, we need to collect the data like this one. So if at all I want to do something, if at all I want to do some modification, then what will be the time effort? What is the data that I need to collect? That also one of the key factor in the implementing. Build the simulation model is nothing but first version, like we have discussed in the actual model here. So once the actual model is done, so we'll be having some set of files, so we'll be having the implementation files, we'll be having some data involved in it. Now say starting phase, again coming to back phase, the actual model we are doing the simulation models, we are doing the complete upgradations in this simulation model. Verifying the simulation model for the validity, checks validity. After finishing building the model, you need to check on the components and the modified performance. Like you need to make sure that what are the things you have modified, what are the things you will be considered for modifications. Like you need to have created data for this one. Testing each and every component of the data you have created. Check the correct functioning and consequences of the specifications. Test the object for combinations. Make sure all the parameters are set correct values. Once you have verified the model, check for its validity. See here. Once you have verified the model, check for its validity. Make sure the functionality of the model is expected and confirm the functionality to be planned. Make the estimation of the most important results. Introduce your model to produce a planning expert and discuss the results. So this is what exactly happened in the third phase of this one. So once you will be having all the things, then you need to verify as well as validate the thing which you have modified. And once you will be having valid verification results as well as validating results, then you need to give these results to the planning department. Execute simulation experiment, collect the results. Execution, like we are discussed in the simulation, I mean procedure of simulations, executing, analyzing, we need to collect all the data with some different things. Once you will be having all the things involved in it, then you need to create a documentation. So before starting the project, then you have to submit this final documentation. That documentation should be like, so what is the actual model, what is the final model. Once you have a simulation project, you need to create the final documentation. This will help you to update the existing simulation model and its components, existing simulation experiment cycles and evolutionary basis. You will modify improvements. Thus, you will be having final stage. This should be having complete data, like what is the actual, what is the final. So what are the things you have modified? So with the modification, what have you achieved? So data for the modification things, like the verifying results, validating results, analyzing the results, checking the results, and comparison, all the things you need to collect in the here, and you have to submit the documentation to the project team so that they will review it for further, and they will, if everything is goes well, they will, then they are going to implement it for the actual model. That is what exactly happened in this one also. If it is existing one, then it should be like this. If it is a newer one, then anyhow we will be having a set of procedure for a newer one, then we are going to start like this if it is a newer one, then directly. So I hope we have discussed this also. So if it is a newer one, then we need to follow these set. Both are almost similar. See, we'll be having the final data, analyzing, executing, verifying, validating, simulating, all these things we also have in the previous one also, I mean in this slide. Still we are collecting it for, this is for existing and this is for the newer one. Implementation nothing but, if it is an existing plant, how we are going to implement a simulation software directly over there. For that one, what are the different procedures we need to adapt, that is called as the implementation of a software or a simulation model in the actual plant is nothing but. Okay, plan a facility, this we have discussed. Okay, this is what exactly the simulation as of now. Now I will explain you some of the advanced concepts in the simulation. Advanced, okay.
Excuse me, sir.
Yes.
Excuse me, sir. Can you go a little slow?
Okay, fine, no problem. I will do that. Advanced concepts of simulation. In this, we are going to discuss about a lot of things like a plant optimization overview, discussion creating a new plant, what exactly digital twin is, a reuse of digital twin, plant simulation benefits and features. We are going to discuss in this session. As said from the starting day, so these are the pillars of industry. Together, we are collecting all this information in a plant simulation, or we are creating each and every operation in the plant simulation. I mean, in the software that is called as a plant simulation. Here, this slide also we have discussed. So these are the things that will be discussed for an industry to change. These are the things that will impact a plant to use a simulation software or digital manufacturing software. So that what will be happen? The plant is having a brief idea. Okay. I was completely forgotten this word. What is the need of these softwares for plant? This should supposed to ask in the second day or third day. I forgot to. Now I have explained you the plant simulation, the capabilities, the features, the simulation, your facility, existing facility, everything I have explained. Now what is the need of this one? Why a plant is needed or why a industry is needed these things? With
To
respect to
meet
this one.
demands of the people
Okay, to meet the demands,
To make profit.
to make profit.
and to make optimum use of all the available resources.
Okay. Any other things?
Limit any chances of failures.
Yes, failures. This slide, that is why I asked you in this one. If at all industry tend to change from small to medium or medium to large, what it should be having? It should be having control on the production. It should be having, I mean, the complete strategy of the production. If at all I want to produce 10,000 components, I'm having 10,000 components demand with me. Now how can I supposed to produce? How can directly I give 10,000 command to the production unit? There is a production department is there, directly I'm going to the manager or some AGM or head to the production, and there like I'm discussing that there is a huge demand in the market. So you are going to start producing the 10,000 components by end of a month or by end of a 2 months, like I have discussed this one. If at all I said the same with an industry person or a manager level person, then he should be having clear idea. This setup is having, like we have discussed all the things. So if at all the plant is sudden demand was raised, so based upon the demand, how exactly they are going to monitor that one, how exactly they are going to manage that. Directly they can't purchase the 10,000 raw material. Why? Because the material is something maybe hazardous or maybe something going to happen, maybe there is a no any space for storing all the data over there. So that they have some plans, some set of procedures for which they need to control the complete production. Out of 10,000, for initially they have ordered 2,000 components. After that they have ordered 2,000 components for the next day. After that they will be ordering 2,000 components for third day. Like simultaneously they are having, they need to have some plan. So in the first day the 2,000 components need to run on each and every mission. In the second day they should be having run on this one. In the third day they should be having run on this one. So that what will be happen, my raw material is not clogged on these warehouses, or it is not damaged in the warehouses. At the same time, each and every mission shouldn't be having that much of load. This mission is having some 2,000 parts involved in the previous station, I mean the conveyor or waiting for the operation. So definitely this mission is going, there will be a bottleneck here. Why? Because 2000 components are waiting for this operation, so there will be a bottleneck. I can't reduce the production efficiency, I can't showcase the values here. That is why they should be having some proper planning or proper control for that one. For every day there will be having 150 parts only produced from a mission. Now the maximum limit is 150. Now at this condition, if I have given 2000 input, then what will be happen? Anyhow only 150 parts will be produced by end of the day at this time. So if I have given 2000 parts aligned, what will be happen? This mission performance charts will show that the production, this is the mission characteristics, and only this much of usage will be there and this much of bottleneck will be there. This will be a failure for this production. So we can't showcase like this. So based upon this 150, so I have given only 200 input per day, so that what will be happen? 150 using and 150, so that at least 60 percentage of usage is there and 20 percentage of bottleneck is there. That is acceptable. Which means the control of the industry based upon the demand, based upon these things, they should be having, the plant person should be having complete strategy on the plant, on the demand, with respect to demand. For that process we are going to use these type of simulation softwares. So not only this plant simulation, even for the robotic applications, even for the process, every simulation will be depends upon this only. Which means by based upon the speed of the market, the demand, anyhow they know that this plant is run for a 360 days. So for 360 days, because of the demand, sometimes they are going to produce 10,000 components, sometimes they are going to produce 10,000 components. Irrespective of that one, they should be having the control on this one. They should be having clear idea on when exactly this 1000 will be coming. So if the 1000 parts are coming, then what are the type of maintenance they need to do? If the 1000 parts are coming, then what are the process they need to adapt? If there is a 10,000 demand is there, then how we need to manage? So how many type of raw material will be needed? How many type of manpower is needed? What is the material handling stations? So in between stations, how the material movement will be there? If there are some overhead cranes, how they will be operating? If they are operating continuously, maybe after 5 days there will be having a breakdown for this overhead conveyor. If this at this type of conditions, how the complete plant behavior would be, that for that purpose, for that thing, we are going to use this plant simulation to monitor the plant behavior, or to optimize the plant behavior, to finally at the end of the day we are increasing the plant efficiency. But considering all these things, like control the plant, control the production, control the process, control the human, for everything we should be having some set of softwares. So that what will be happen, we can predict the demand, we can predict the maximum extent, we can predict the validation results, we can predict everything. Suddenly while creating a model, I don't know when exactly the demand will be, so I have created the model for 10,000 units. Because of not that good thing in the market, the product was completely, my production demand was completely reduced. Now finally it was coming to 1000. My demand is only 1000. The plant is designed for 10,000. Now I am going to run for 1000. Now what will be happen at this condition? Now what are the different alternatives I need to have? My plant is having complete CNC machines and everything automatic ways. If by using all those things, if I produce 10,000, what will be happen? There will be a huge loss. Why? Because there will be energy consumption, all those things will be considered. So if at all at this condition, what I need to do, like we should be having complete scenario, complete planned scenario in our hand for the next 1 year or 2 years. For that purpose we are going to use this plant simulation for controlling the complete plant. That is one of the key things. That is why industry changes will always, if there is industry change, definitely then it will be in place on this plant simulation. If the plant is utilizing some, not only this one, digital manufacturing softwares. Digital manufacturing softwares is nothing but where the plant can be operated digitally, where the plant can be converted into digitally, like the plant simulation where we are going to create the facility in a virtual environment. A robotic simulation where we are going to create the robotic applications virtually by using a software, so that what will be happen, the time will be reduced. Same with the process, same with a human simulation, same with demand ratios also. There will be pre-actor software. In the software they will be having complete details on how the input is coming, how the output is going, how the schedules will going to happen in the market. If there is a sudden impact of demand, if there is a sudden rise of demand is there, how I need to monitor, to whom I need to contact for raw material. Maybe the supplier for the raw material is having only 1000 parts with me, he is going to produce 1000 components by end of a month. Why? Because he is going to produce, he is going to do some sort of work for that input. So now because there is a sudden demand of 10,000, now how can I supposed to ask that person to produce 10,000 components in a month, or in 2 months or 3 months of tenure? The maximum capacity of him is 1000. at the time what I need to have, what will be the alternative values, what is the things I need to purchase, if there is only limited number of tools that is available in the market, if there is a limited number of coolant oil available, if there is a power breakage, like I need to have all the things. To consider all those things, there will be having some digital manufacturing softwares with which I can control the complete plant without with I mean with respect to any demand. So if the demand is 0, then I can operate. If the demand is 100, I can operate. If the demand is 10,000, I can operate. If the demand is 1 lakh also, I can try to manage it by using these digital manufacturing softwares. That is one of the main capability or main necessity of these softwares. Okay, now see, plant optimization overview. Plant optimization overview is nothing but, like we have discussed this word previously, optimization. Optimization is nothing but utilizing the same resources. I mean, if at all I'm having 10 missions only, by utilizing the 10 missions I want to increase my productivity. That is called as a plant optimization. Or else, one more example, I'm having 10 missions, and by 10 missions I'm getting 1000 number of components, and I have tried to optimize it, so that what will be happen, by using 9 missions I'm getting 990 parts, or 900 parts at least, or 950 parts. This is manageable. That is called as optimizing, utilizing the resources which we are having and trying to improvise the process, trying to improvise the production, or limiting the number of resource missions which you are having, the resources which you are having, and trying to maintain the same production. Just like I'm having 100 CNC missions and I'm producing 10,000 components by 30 day for that, for every 30 days. Now I want to reduce from 100 to 90 emissions, and I am trying to maintain the same thing by working it for 1 hour more. These 100 emissions are running 15 hours a day, so that I am getting 100 10,000 components. Now by using 90 emissions I am trying to run it for 16 hours, and I am trying to maintain this one in the second case. Now what happened, this is called as optimization. So that what will be happen, these 10 missions cost, these the difference 10 missions, these resource cost, everything I can supposed to save. At the same time I can invest that on the extra 1 hour. So that what will be happen, it is balanced. At the same time there are 10 more missions that are kept vacant for some other process. I can see in that perspective also. That is called as optimization, which means utilizing the facility which we are having and improvising the profit efficiency of the plant is nothing but optimization. Optimization would be any type optimization, like a process optimization, product optimization, human optimization, plant optimization, robotic optimization. Everything can be optimized. Power optimization, facility optimization, resource optimization, these are the different things we can go for. Even throughput optimization is also there, which means we are into increasing the final efficiency by limiting the resources. Okay, that is what exactly plant optimization is. So plant for optimization, what is the key things for a plant optimization, what are the things I need to consider, or what are the things I will be having? Like, first thing is profitability. At the end of the day, same application 1900, and I'm getting 10,000 components. What will be happen finally? At least there is a 1% of increase. Even though there is a 0.5 percentage, that will be increase in my production. That is called as the profitability. For this perspective, we are going to use this plant optimization. Second one is a throughput. Same thing. Here 100 missions. Here there are 90 missions. Same here I limited the number of missions. I have increased the throughput. So that what will be happened? My production, I am maintaining the production. It is called as a throughput optimization, which means limiting the number of things and increasing the throughput will also be tend to get the desired one. That is throughput optimization. For these things, for plant optimization, definitely we should be having content planning. Why? Because I don't know when we have discussed this one, day two or day three, day four, I don't know. So we have discussed this also, content planning. We should be having a complete idea on the plan which we have prepared. So if you are the person who have created the layout, you have created the layout like this, and this is the layout you have defined. So maybe if at all you want, there is a failure here. There is some set of failure you have identified. Now I hope it's easier for you, right? So where to modify it, how to modify it. You should be having a clear idea on if the process failed at this station. Then you should supposed to remove this one, or you should supposed to add something in it so that you want to run it. Or it should be like a planning. So how to plan it? If there is a failure here, now what is the alternative thing you need to have? That is nothing but a content planning. If the mission here it was failed, Now how I need to do? There is one more mission here. Now the part need to come to this location, and it was done, and it will be going to this location for the till this mission need to repair. So this is what the procedure they want to adapt. So how it is going to run? So what will be the alternative? How much material handling there? So how much time it should be taking for a part to come here and again come back to its original location? So what is the difference? So with the change in plan, how what will be the impact of this one in the production? All those things are nothing but a content planning. Energy efficiency, like in this application, this is the simple application where I explained this energy also. So if at all I'm talking about energy efficiency, what is happened here? Here they are using 100 missions, here I am using 90 missions. This mission is using for 15 hours, maybe 15 for every hour there will be having 1 megawatt. So 1 megawatt usage is there, and there will be having for every day there will be having 1 megawatt. So 15 megawatts of power is utilizing 500, sorry, 15 megawatts into 100, 1500 megawatt per day. Here I am utilizing only 9. So that what will be happen, at least it will try to reduce. Here I am increasing the day, I mean increasing from 15 hours to 16 hours. So that what will be happen, here it will be 16, here it will be like a 16 into 90. Maybe it is increased or decreased, that is second perspective. But what will be happened, there is a difference we are going to adopt. That is what exactly energy efficiency. In between, what are the missions that I need to use? If at all there is a mission that is not utilized more at that instant, do I need to use a conventional mission or do I need to use a CNC mission? If the application is small or if the application is limited at that instant, what are the different applications I need to adapt? What are the different missions I need to adapt? So here there is a simple application where the parts are coming for every 1 minute. So here I have used a robot to pick a part and place on the another conveyor. Now at this application, is it acceptable? Is the robot really doing its if a part? Instead of a robot, what will be happening if I place a human over there? So what will be happening if I place a human? How much energy I will going to save? Why? Because for every minute there is a part is coming and there is a loading. So which means the robot need to have 24 by 7 power supply. So maybe it is charging some 10 megawatt of power, 10 megawatt so of usage. Now instead of a robot, if I place a human, what will be happen? Human is also doing the same application, is a picking a part, is placing over there, or is waiting for some till 5 minutes, so that there are five parts that are coming here, and together they are picking a part for five parts and is placing on a bin here. This can also be performed, so that what will be happen, the power utilization will be reduced. This is one of the thing, energy efficient. Plant optimization can be done for this energy efficiency also. Process optimization, there is no need of explaining this process optimization, I hope so. So we are doing this plant optimization for increasing the efficiency, so that what will happen finally, our process can be optimized. So how exactly it is optimized? So for the optimizing the process, what are the things I need to adopt? If it is a process layout, so then there is no need of process optimization. If it is a product layout, then how can I supposed to improvise the process or improvise the process optimization? That can also be checked in this plant simulation. A digital twin, this we are going to discuss in the next slide. Clear? So these are the different areas we are going to consider for this plant optimization. If we are doing plant optimization, then we need to consider all these things. Finally, we are getting profitability, so we are going to increase the throughput. We are going to go, I mean we are going to prepare a plan that should be modified anywhere at any time. And finally, if you're doing a optimization, which is nothing but energy can be reduced, utilization of energy can be reduced. Process optimization is also a part of the plant optimization for increasing the plant efficiency. And one of the key thing is digital twin. Digital twin is nothing but creating the complete model in a virtual environment. See, this is what exactly digital twin is, which means this is the actual plant. The same missions, the same conveyor, all those things will be same in the actual. I'm converting the same, I'm converting a replica of the actual plant in a software, is known as a digital twin. Okay. Now,
Excuse me, sir.
yes.
सर ये डिजिटल ट्विन एक बार एक्सप्लेन करना.
No problem. I will explain you. There is a complete slide for this one. At the time, I will explain you all those things. Okay. Now, decision makings are decisions we need to adapt. Planning, impact of change in production process, reduce WIP inventory, utilization of missions, tooling requirements, manufacturing changeovers, bottlenecks, resources, impact of failures, project phase involvement of automation, energy efficient, alternative for improving throughputs. Have we discussed these things or not?
Yes, sir.
Have we
Yes, sir.
discussed?
We have discussed.
We have discussed
Yes,
in
sir.
some separate layout. I have created some separate layout for these things. Okay, now you have defined. Now these three are interlinked with each other for creating a model. For creating a model, these are the things you need to consider. How exactly, which means these are both are interlinked. So if there is a something happened here, so automatically the plan will be changed. If something happened, I mean, if you are going to modify this whip, automatically the plan will going to change. If their utilization of missions will be changed, automatically the plan will also be changed. These both are interlinked with each other. At the same time, these three are also interlinked. Plan will always depends on the manufacturing, at the same time project. Okay. Now we'll comes into digital twin. One of the key area, one of the important aspect of the plant simulation also. Not only for plant simulation, for digital manufacturing or advanced manufacturing. Okay. Digital twin is nothing but, I hope you know twin. Twin is nothing but replica, right? Twin is nothing but a replica. See here, digital twin is nothing but creating the same thing in a virtual environment is nothing but digital twin. Okay. Here there are three types. I mean three, that is called as a digital product twin, production twin, and performance twin. Product twin is nothing but creating a component. See here, I have prepared a tire here in a virtual environment. I mean, I'm having an idea with me. I want to produce a tire. So how exactly it need to be defined? So I'm having some sort of ideas or innovation for that. So I have given a skeleton for that one by using a digital software or by using this is created in the Siemens NX software. Siemens NX I have created in Siemens. So with the software, what happened? I have given some skeleton to the idea which is in my mind. So that what happened? So this is what I am going to prepare. So this is the product I am going to prepare. That is called as a product twin. Or finally there is a tire which is in the market. I want to do some modifications for that one. So based upon the dimensions, based upon the all the nomenclature involved in that one, I need to create a digital file that is called as a digital product twin. If we are preparing a product digitally, if you are preparing a product or component or anything, maybe a sanitizer bottle, maybe a remote laptop, computer, fan, anything in a virtual environment and a software, then we'll call it as a product twin, digital product twin. Clear?
Yes, sir.
So performance वाला एक बार फिर से थोड़ा बताना कैसे होगा?
मैं परफॉर्मेंस तो कभी तक नहीं आया. I am still at this stage only. Okay. See, this is called as a digital product twin. Now, production twin. Production twin is nothing but plant simulation. Okay. This is a Siemens NX where we are creating the product. This is a plant simulation where we are creating the facility of the plant. Facility, which means all the things involved in a plant that are going to create here. So if at all I want to produce this type of tire, if at all I want to manufacture this tire, then what is the setup I need to have, what are the machineries I need to have, what is the procedure I need to adopt, so how the material is, how the raw material entering into the plant, finally how the tire is coming from the station. So all those things we are creating digitally, that is called as a digital production twin. Okay, creating a plant, creating a facility for creating a product is nothing but production twin. So anyhow we are creating it by using the software that is called as a virtual, in a virtual environment, that is called as a digital production twin. Here product is nothing but the part which we are going to manufacture. For the plant we are going to prepare a manufacturing facility, that is called as a production twin. Okay. Now, performance twin. Performance twin is nothing but the complete nomenclature of the product. I mean, how I need to tell, how I need to explain. CAD, CAM, CAE, CAD, CAM. There is one more thing. CAD, CAM, SIM. CAD, CAM, SIM. Right? These are the three things. I hope you know this one. CAD, CAM, and
Yes,
SIM.
sir.
What is SIM?
Yes, sir.
What is SIM?
Computer integrated manufacturing.
Okay, correct. Now, what exactly it describes? I hope you know the diagram.
Automations.
Not automation. Let me erase
So
it.
a complete life cycle of a product.
Not exactly. See, there is a relation actually. I don't have that image with me. CAD is a, if at all I'm considering about CAD, then CAD is a part of CAM. This is CAM, and this is part of SIM, which means if at all you want to manufacture anything, then CAD should be mandatory. Why? Because without having any design, you can't manufacture anything. Now, if at all you want to manufacture any product, then there will be need of some set of procedures, some set of layout, some set of missions, manpower, everything. Then that is called as a SIM. SIM is nothing but factory. Okay, simple example. SIM is nothing but factory. So in factory, everything is involved, from the raw material entering into plant, from the watchman of the plant. See here, there is a gate here. From this gate to exit gate, everything involved in a sim. If at all I am going to operate each and everything by using a computer, then it is called as a computer integrated manufacturing. How the man is entering into the plant, how the humans enter into the plant, how the material is entering into the plant, how the process is adopting here. So where how many type of layouts will be needed, so how these will be monitored, how the material will be placed here. So where are the washrooms, where is the rest area, what is the time break, what are the shift calendars. So everything involved in this plant is integrated with a computer, then we'll call it as a sim, computer integrated manufacturing. In this sim, CAM is a part of it. Why CAM is manufacturing? If at all I want to monitor any component, any, if at all I want to manufacture any type of component by using a CNC machine, then definitely there is a need of a programming, part programming, G codes and M codes. That is why sim sim is having CAM. Okay. Now, if at all I want to manufacture anything, if at all I want to prepare a post process, or if at all I want to prepare some part programming, then what is the immediate thing I need to have? I need to have the product nomenclature or a product design with me. That is called as a CAD. So this is the relation. SIM, CAM, CAD. CAD, CAM, CIM both. Okay. CAD is a part of CAM, CAM is a part of CIM. CM is nothing but complete factory involved in it. That is called as a SIM. Clear? CAD, CAM, CIM relation. Now, just a second. This is called as a SIM. Apart from this, we will be having customers also. So what is the concept? So what is the design we are adapting? Where is the raw material that is coming from? How the manufacturing is happening? This is CAD, this is CAM, and these are the rest of the components. How the human involved in it, how the labor is working here, how the executing team I mean the managing team is sitting, how exactly all these things will be happening. That is called as a performance twin. So by considering everything for that product, starting from the life cycle, so how exactly it was started, PLM, so how exactly it was started, so after that what is the design, so where exactly I need to purchase the raw material, how it was manufactured, what is the different frames of testings I need to produce, so how I need to produce the parts, so after that how exactly it will be distributed to the customer, so what will be the feedback, again what is the concept, everything that is involved in this is nothing but digital performance twin. Okay, this with respect to the part. I mean here we are going to purchase a, I mean prepare a part in the product. Here we are going to prepare the setup for that part. Here we are going to monitor the complete life cycle for that part is nothing but performance twin. Clear? Part, production,
Yes, sir.
and performance. I mean part, product, and life cycle of the product. These three things. So if at all I'm using some digital environments to operate these things, then we'll call it as a digital twin. In the digital twin, then there will be having three things: product, production, performance. These will be handled by design engineers, these will be handled by manufacturing engineers, these will be handled by managers, production managers. Okay, some of the benefits for the these things, benefits for modeling a digital twin. So if at all we'll be having a digital software for creating any type of product, any type of product, then it is easier. Why? Because we are using a virtual environment, we can't directly go to a machine and we can't change the part, I mean dimensions of the part. Here in the software we are doing anything. So instead of a circular tile, if at all I prepare rectangular tile, what will be happen? I can check this also. I can check any type of component. If at all I prepared circular layout, in that I have prepared some holes, directly holes on the external surface of this one. So what will be happen if this I have prepared with some concept I have prepared like this? So what will be happen if I prepare like this? So I can directly check in this design platform. It's a low risk. Decisions are based on the analysis, are not on the speculations. which means once I have created a hole, see this design, I have created a tire with holes on the sides, continuous holes, which means a pitch of having some 5 centimeters. I have created a number of holes on the tire. Now this design is not finalized yet. When it was finalized, so once the design will be entering into analysis, then you need to do some analysis part. Once the design is acceptable from the analysis results, then only you are going to produce it. So here I am not not altering any design. I have created something and I have given it for the analysis. If the analysis results are coming well, perfectly, then I can produce it. I can produce it by using this one. Productivity and investment ratios, possibility of doing more better opportunities for increasing productivity, which means nothing but optimization. Here we can optimize the plant. Here we can go for the optimization part in the plant simulation. Whereas in the process, product visibility, high rate of production, quality improvement, faster troubleshooting. So now we will be having complete life cycle of the product. So if we are having the life cycle of the product, then we will be monitoring at each and every phase. If the raw material is having some limitations, if the production CNC machine is having some limitations in producing a part, then I can troubleshoot it, why exactly it was happening. After that, maybe there is having some quality standards, quality aspect problems. Now I can work on the why exactly the quality is not meeting, how can I supposed to improve that I can directly go with the performance. These are the some of the benefits for creating a digital twin. Okay. Reuse. Now you tell me what exactly is this reuse digital twin of plant. Please this one. I have explained you digital twin. What is this reuse digital twin? What it should be?
So suppose there is any upgradation, then we can reuse the digital twin and means change anything which we are going to upgrade.
Yes. Perfect. See, if it is existing one, which means now, sorry, existing one. I have created a plant. I have given all the modifications involved in it, and I have prepared the plant. And this is my final model. I have prepared F1 is my VF1 is my final model for this plant. Now I have saved in the master database. Okay, after an year, someone has find some fault in it. Now they want to modify it. Now for modification, it is not necessary to start from the basics again, to start from the zero, which means mission 1, mission 2, mission 3, mission 4, mission 5, not like this. So why? Because I'm having already a reference file involved in it. They can directly download this file and they can reuse it. That is called as a reuse digital twin. This reuse can be product, for product also we can do we can go for the reuse. If a tire is there, the profile on the tire is not that much good. Now what will be happen, I can download this digital file and I can upgrade the tire profile. From this to I will be using some lines like this. I can go for the production. I can change the directly. I can use this one as a reference and I directly remove these external patterns and I can use these lines. That is a reuse. Instead of creating a complete tire from scratch, I can go for these modifications. Similar with the production also. If there is a layout is fixed here, for that product there is a L type of layout. Now I have changed the external structure of the tire. So which means there are some CNC machines which are programmed for this helical cutting like this. Now I want only straight cuttings. For that, what will be happened? So I there is no need of creating from starting. Directly the section, maybe the C section is cutting the tires external grooves. So directly I can replace this section. Directly I can modify this C section, so that what will be happen? I can modify this one. That is what exactly a reuse digital twin is, which means we can directly reuse it. We can modify the existing thing. For reusing this one, there are some set of rules that need to follow. Simulation based decision making, which means use production plans as input to visualize plant response. This is the plant which they have actually prepared, for which it is taking some 3 hours of time to produce a part. Now if you have defined this one, what is its impact? So whether it will be producing in 2 hours or 3 hours or maybe 4 hours, so if it is this time, then what is the impact? So what is the production schedules? All the things you need to first of all monitor, you need to collect the results and you need to showcase it. That is the first thing. Second one important thing is Brownfield project. This is nothing but test logic modifications in digital twin before implementing on the factory, which is one of the key factors. Why? Because here, see in this one, there is a section process C. This is process C. In the process C, there will be having 10 CNC machines. All the 10 CNC machines will be uh, monitored by some charts. So what have you done? You have modified all the missions. You have modified the programming. So if you have modified, what will be happened? So, but this chart will show the old results only. This won't be updated. Why? Because it was interlocked. When your project was fixed, when you finalized, then all the components will be locked for this mission itself. You can't modify that one. If at all you have modified this one, then you need to open some coding and you need to remove this one, and you need to add some new chart, and you need to add all these 10 missions to this process, and again you have to lock these things, then only it will be updated. Otherwise what will be happened? So you have given the new operations for the 10 missions, and each and every operation will be taking 4 hours, and previous chart is for 3 hours. It will be showing that statistics only, not actual statistics. That is called as a brownfield project. It's nothing but test logic modifications in digital twin before implementing on the factory, which means on what aspects, where are the different areas where you have modified. So if you have modified, then you have to check all the codings involved in it. You have to remove all the necessary things, all the necessary charts involved for that one, and you have to update it to the new one, and you have to check the logic which you have defined, and you can run the simulation continuously for n number of runs. At the same time, you can verify as well as you can validate it. So once you will be having the results that will differ from the actual, then it is a correct model. Then you need to save with some other version, and you need to showcase all the results. That is called as a brownfield project. Generally in industries, this will be used. Why? Because there is already existing plant, existing layout will be there, that is created 5 years back or 6 years back. So all we need to do is modifying the plant, modifying the results which you are updating, or getting, I mean, optimizing from the results which you have obtained. That is what exactly we need to do. Now we need to download the part, and we need to save it as a reference, and we need to do the modifications. We need to remove the codings involved in it. We need to remove the locking that is involved in it, and we have to run the thing. That is called as a brownfield project. With this, what will be happen? Our time will be reduced. So time for creating the project from starting, that will be reduced. Why? Because there is already a reference file, there is already a file that is built. So we are modifying only in one section. The plant is having 20 sections. Out of 20, there is only one modification in one section. Now why to create all the 20 sections? It will be time consuming. Again, we don't know that whether the model which we have created will be completely mappable or not, or manageable or not, or maybe it is having flaws. It should be having some flaws. So to overcome all those things, we will be using the same old file as a reference, and we can update it, and we can save it. And we are not disturbing this one. This will be a master file, and this will be used as a master only. So we will be saving all the modifications with some new project, and then and we'll be sharing it to the validating team. So that validating team will supposed to validate it. Okay. In plant, what will be happened? For this plant simulation, there will be having n number of teams. One team is for creating, I mean modeling. Sorry, one team is for completely modeling. Another team is for coding. There is some set of coding involved in this thing also. Second team, this is one team, and this is second team for coding. Third team involved for automation. If they want any automated things, then they will do the automation thing here. Fourth team is for verifying or testing. Fourth team is for testing. Fifth team is for validating. Data collection team. Last one is data collection. Each and every team is differ. See, if you have created some flaw in the model, and the second team don't know this one, directly they will create some coding based upon the thing which you have given, and the third team will do the automation based upon the 1, 2, and 3 inputs. Same thing in the validation team. Fifth team will do the validation. They don't know all the things involved in, they don't know the manipulations which you have done in the project. They will do the validation, and they will collect some results irrespective of the results, whether it may be a good or bad, that doesn't matter. So they will collect the validation results, and they will hand over it to the next department or for the next thing for reviewing. So now what will be happening? Your model is up to this, it was running perfectly, but in validation it was failed in the first day itself. So automatically the process is going to fail, or something going to happen which you have created, or something flaw is identified. So this is what exactly, if you are the person, if you are the only person, you are doing all the things, then you know each and every parameters. So you know each and every area where you want to check the plant. So in this modeling section, you have modified only 10th process, but this team don't know that one. Directly they will coding for each and every component. They will coding for starting to ending. They will checking all the coding involved in this one. And third team will also do the same thing, and fourth team will also run the complete plant, not only the 10th one. They will run the complete from starting to ending. Same with the fifth team validation. They will run the complete 20 process involved in the plant, and they will check how exactly the material behaving will be. So if you are the person, then how exactly you will do? So you will be directly checking the 10th process, 10th coding, 10th automation, 10th verification, 10th validation, 10th result, and you will be adding this result to the master results. It is not no way acceptable. That is why the plant will be having different teams. So all the teams will do the same, these aspects. Clear? Okay, using the
Yes, sir.
facilities, creating robust production lines, designing and building a plant project is a challenging task, involves high investment, expertise, right team, suppliers, efficient coordination and communication. That is why these things. So this project completely depends upon n number of teams with n number of engineers involved in it. This plant simulation is not a single man project. For the plant simulation, if at all you want to create a model, then there will be having some team of 10 to 20 persons. So out of which they, like already told you, they will be distinguished based upon the expertise. Now each and every team will be having 2 to 3 persons involved in it. Together they are going to finalize the model once you have prepared. Just like the software, some will prepare the coding in behind it, some will prepare the external coding, some will prepare the php external things, some will prepare the icons on the visualization reports, some will check on the database how exactly to connect it, some will be work on the appearance, external appearance. Finally, some will going to check the testing of the complete page. Different pages. Same with the plant simulation also. So we'll be having different teams, and without having any proper coordination as well as communication, this will going to fail. Okay, this we have discussed. Uh, shall we continue, or shall we stop with the today's session? It's up to you.
So we can continue from next session.
Okay, fine. Okay, I will
Yes, sir.
explain you this page itself. This is the only page, and after that we will be entering into some videos. So I will be showing you that videos tomorrow itself. Uh, Benefits. Till now, we have discussed a lot of things. Now, what is the benefits of using plant simulation? Graphical model visualization, simulation, and optimization, which means, so if you are having a model, it is easier for you to see that model in a virtual world so that it will be identified. So, if my plant is visible like this in a triangular shape, which is no way acceptable, I can, with the visual reports, I can monitor it one. So, I don't want this triangular one, I want a rectangular one, or I want a oval one like this. So for this one, how exactly I need to monitor this one? So based upon the visualization, I can go for the simulation as well as optimization. All these things can be graphically it can be visualized, so that at any point of time I can see the statistics. At this point of time, how the material is behaving. So at this point of time, how the machine is behaving, how the human is coming. So how the conveyor is looking after full load. So all those things can be graphically represented. Support of instrumentation based on calculations. At the same time, factory layout optimization. All these are some of the benefits which we have already discussed. Results: calculation of output quantities, throughput times, asset cost, buffer allocations. Buffer is nothing but, okay, buffer I will explain you when the software comes. So we can directly monitor all these things, like how much output is coming, how much throughput is coming, what is the total capital cost I need to have, how much buffers I need to use in between stations. That can also be calculated. Inputs, like, so what will be the processing time I need to give. So if at all I want to run the plant, run the complete model, or run the industry with respect to time, which means I want to run this industry for 1 week and after that I want to shut down. So with respect to time, how the industrial behavior will be. With respect to parts, I want to produce 1,000 number of components irrespective of time, which means the last machine is going to produce 1,000 part. So for which, so if it will take 1 month, it doesn't matter. If it will take 5 months, it doesn't matter. So that is called as a product quantity simulation. It is called a process time simulation. Layout, how the layout will be given. So what are the type of inputs I need to give for the layout, material flow logics, availability, utilization levels. These are the some of the inputs for which we need to give, so that we will be getting all these results. Enhance productivity of existing facilities. This is called as optimization. Finally, we are utilizing the same facility and we are trying to improvise the efficiency of the plant. That is nothing but optimization. This is what exactly we are doing in the plant simulation. Reduce investments in planning a new facility. This is one of the things. If it is a newer one, if it at all I'm starting a newer plant, then, so by creating n number of models, By creating, if at all I am starting a new plant, then I need to create, by using this software I can create some 20 or 30 models. Out of 20 or 30, 25th model was finalized, because it's what will be happened, my so I'm having n number of plans in my mind, so that I can invest, I can save my production fee, I can the capital cost involved in it, I can save some of the cost that will be involved in it, all the things I can be saving. That is called as a reduced investments in planning for a new production facilities. At the same time, it is difficult to conduct experiments on a running plant. That is why there is a reason of virtual plants for this one. It's a statement like, if it is existing plant, if at all I want to do a modifications on the existing plant, then what will be happen? It is always a difficult. So if it is a running industry and I want to remove this mission and I want to add it some other mission here. So at this time, what will be happen in a running industry? It will be having a lot of impact. So instantly, I need to stop the production. I need to remove this machine. I need to change over the process, and I will be like this. So it will impact on my production. So if this process failed, what will be happen again? There will be having a use loss. So for which there will be having this plant type simulation type of softwares, so that I can clearly see. So if at all I change the process, then what will be happen? If at all I change the this one, so what will be its impact? I can directly check that those things. That is what exactly the main capability of this software is. Clear?
Yes, sir.
Okay.
Yes.
Fine. Any doubts so far? Is it clear?
No, sir.
No.
Okay, fine. If it's clear, then I think we'll end the session for today's session. Okay. So then have a great day and be safe at home, guys.
Thank you, sir.
Okay.
Thank you, sir.
Don't go
Thank you,
outside.
sir.
Why? Because COVID is completely increasing outside. So be safe and be at home.
Thank you, sir.
Okay. Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Okay. Thank you.
Thank you.